Hello everyone, welcome back to my channel. Today let's review a medium question that I solved around 3 months ago. Looks like it took quite a few tries, so let's try it again. This one's called maximum sum of two non-overlapping subarrays. So basically you're given an integer array nums and two integers, and you want to return the maximum sum of elements of one type and another type that they're not overlapping. So non-overlapping, let's go ahead and get all the subarrays of size 1 and all the subarrays of size 2 and keep track of their boundaries so that we have both types. So let's call this first and second. And for I in range, length nums minus first len plus 1. So we're going to get all the subarrays of length first len. Subarray is nums of I to I plus first len. And then what we're going to do is keep track of the boundaries and the sum. So to keep track of the boundaries, how about let's create a default dict of type integer, because we know you're never going to have the same boundary again. So then we can just keep track of the left bound and the right bound with I and I plus first len. And then first, and make this a tuple. So first of tuple I left and right is equal to sum of subarray. Let's print first so you can see what I mean. Okay. Equals to left and right. Let's say this. Okay. So now we got 0, 1 has sum of 0, right? 0, 1. 1, 2 has sum 6, vice versa. And let's do the same thing with second. So we can copy this, and second len, and second goes to sum of subarray. Let's make second a dictionary as well. Okay, so now let's print second and first. So we now have every subarray of size 2, their boundaries and their sums. So 0 to 2 has a sum of 6, 1 to 3 has a sum of 11, 6 plus 5 plus 2 is 11, vice versa. Cool. Now to find non-overlapping subarrays, let's order these dictionaries in reverse order so we can try to find the largest sum, because that's our goal. So first equals dict of sorted key equals, or first the items, key equals lambda x, and we want to sort by x1 or negative x1. So opposite way. Do the same thing with second dot items, and this should give us excuse me, the biggest sums at the end, but they have to be non-overlapping. So now we can just go through. I guess we can just make this a list even instead of a dictionary. Okay. So now, okay. Now we just got to go through both lists. So for I in range, length first. For j in range, length second. We know the first one is going to be the biggest if they don't overlap. So how do we make sure these don't overlap? So if first of I of 1, so if second of I of 0 is bigger than first of second j0, so 7 has to be bigger than 8, is bigger than first I of 1, and second j of 1 is bigger than second of j of 0, and so this guy is bigger than this guy, and first of I of 1 of 0 is less than first of I of 1, then let's make a result. Result is max of result of this plus this, 9 plus 13, which is just going to be first of I negative 1 plus second of j of negative 1. Return result. This is not, I don't think it's correct because, okay. So that's the problem, because now we have these tuples. Let's call this f and s. Probably first I of 0, second j of 0, let's print first of I and second of j. Okay, this is kind of nasty, but how do we make sure this? Maybe first I 0, second j 0. Okay, so now f and s can be this and this. And now so how do we make sure these are non-overlapping? Well, if f of 0 is bigger than second of 1, this is bigger than this. First of 0 is bigger than second of 1, which is not in this case. So, or maybe first of 0 is bigger than second 1, and f of 1 is bigger than s of 0, then result is max of result of first I of 0, first I of negative 1, plus second j of negative 1. We're just trying to extrapolate. So at least partially that's correct, but we have the other condition where second also has to be satisfied. So if s of 0 is bigger than f of 1 and s of 1 is bigger than f of 0, same thing, right? So flip the other way around. Ooh, okay. Oh, let's see here. Supposed to be 4. Okay. Overlapping probably means less than or equal to. Use this. Okay. Oh, wow. Okay. Kind of a messy one, but the constraints are small, so it's not going to be penalizing. And there you go. Passes all test cases. So it's a pretty messy solution, but it does work, and I did come up with this on my own. So hopefully that made sense. And yeah, that's it for this video. Thank you for watching, and stay tuned for more.